we need to talk about something that really matters, like matter. Yeah. Specifically, there are different kinds of matter and different ways we can classify it, and that's what I'm going to talk about in this little mini lecture. So just quick review, matter is anything that has volume and mass. Just about everything you can think of as matter. There are a few things that are not matter, specifically energy and forces. So light is the easiest example of something that's not matter. It doesn't have mass. You can't measure the volume of light. Same with sound, etc. So those are not matter. But everything else in the universe is matter. Now, classifying it. Matter can be a mixture of different types of things, or it can be a pure substance. I'm going to talk about mixtures first. We got two different ways to think about mixtures. There's homogeneous and there's heterogeneous. Those are big words. I'll talk about those things in a bit. But a mixture is obviously when you've got two different kinds of matter or more and they're mixed together. That's why it's called a mixture. Okay? With a mixture, you can separate the pieces of the mixture using physical processes like boiling or freezing or filtering or just hand picking pieces of the mixture apart. You don't need a chemical reaction to separate out a mixture. You can use physical processes. So heterogeneous is the first of those big words. And up here in the upper right corner, I've got a little diagram showing how in a heterogeneous mixture you can see where one type of matter stops and a new type of matter starts. So hetero, that prefix means different. Heterogeneous, different phases, different chunks. You can easily see it. So examples, chocolate chip cookies, granite. There's different types of matter in that rock. Oil and water, you can see. Salsa, as they say up in Canada. Can you believe that? They say salsa, taco, garage. It's weird. That's heterogeneous mixtures. Homogeneous, okay, homo means same. That's a prefix. Have you ever wondered why homosexual is the way it is? Homosexual, same sex. Homogeneous mixture, same phase. It's evenly mixed. You can't see the difference between the two parts. So like this fruit punch pitcher, it's a mixture, right? There's sugar, there's flavor, there's water, different things in there, but you can't really see the difference between those three. It's all one phase. Milk is a mixture of lots of different things. There's proteins, there's fats, there's water. Salt water. Can you see the salt in there? No, it's dissolved. Lotion is a mixture of many chemicals. You can look at the label and you can see lots of different chemicals in there, but it only looks like one thing. It's this white creamy stuff, and that's all you can see. So homogeneous, same. It all looks the same. That's what the prefix homo means. Now a pure substance, I'm switching away from mixtures. Okay, a pure substance and a homogeneous mixture, they look kind of the same. But the difference here is that with a pure substance, it not only looks like one thing, it actually is just one thing. It's not a mixture. It's one substance. An example in our picture is here O2 gas. That's the formula for oxygen. If you've got a canister that you bought that's full of oxygen gas, that's a pure substance in there. There's only oxygen in that canister. Okay? It can be either an element or a compound. The picture here I have is a pure element. It's only oxygen. Okay? Pure substances are just that one element or that one compound, and it's the same throughout. You can't separate it with physical stuff. If you have a glass of pure water, okay, and you boil it, the water vapor that it forms, it's still water. Water is H2O, hydrogen and oxygen, and the only way to get that hydrogen apart from that oxygen would be with a chemical reaction. And when you do a chemical reaction, that changes what it is. Okay? So that's a pure substance. Again, it can either be an element or a compound. An element is made from one kind of atom, and we look on the periodic table of atoms to see what those are. Compounds are more than one type of atom. This drawing right here looks to be water. There's maybe 2 hydrogens and 1 oxygen. They're bonded together. But it's all the same compound, so this is still could be pure water. This might be nitrous oxide. There's a nitrogen bonded to an oxygen atom. But they're all the same. It's all the same compounds. So this whole sample is still a pure substance. Okay. Compounds. 2 or more atoms. I just talked about this a whole bunch. You can chemically separate them. Chemical reaction only, though. Here's a few more examples. Salt is NaCl. That's sodium bonded to chloride. They're chemically bonded together. Sugar, C6H12O6. That's a big clump of atoms all in one molecule. 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms per clump. And each clump is a molecule. So here's kind of a flow chart showing you that hierarchy of everything that I've cruised through here, right? Matter can be either pure or a mixture. If it's pure, it can either be one element or it can be a compound, more than one element bonded together. For mixtures, you can either have a homogeneous mixture where it's perfectly mixed and it looks like it's pure even though it's not. And with a heterogeneous mixture, it does not look pure. It looks like a mixture, like a bowl of cereal or something. And I think that might be all I want to talk about in this video. I could talk about the rest of these, but that's enough for now.